Hello and welcome to this video in which we shall discuss how to graph rational functions using everything we've learned about asymptotes and intercepts. So in order to graph a rational function, we need to figure out what the vertical asymptote is. The vertical asymptote is obtained by solving for the denominator. So for the vertical asymptote, we have x plus 1 equals 0. So x equals -1. Let's click on vertical asymptote and drag the asymptote to -1. For the horizontal asymptote, we put x as a very large number. So y equals -1 over, of course, this is neglected, so -1 over infinity, or 1 million, or whatever, -5. So this becomes 0 minus 5, which is -5. So we're going to click on horizontal asymptote here. My apologies. And we're going to drag it to -5. Now we want the x-intercept and the y-intercept. So let's get the x-intercept first by putting y as 0. So for the x-intercept, we put 0 equals -1 over x plus 1 minus 5. Take the 5 to the other side, so 5 equals -1 over x plus 1. Take this to the other side. So we get, I'm going to write it on the left, we're going to get 5 times x plus 1 equals -1. So 5x plus 5 equals -1. 5x equals -6. And x equals -6 over 5. This is the x-intercept. So this is a decimal. I should be able to plot it roughly. So -6 over 5. You divide 6 by 5, you get 1 and 1 over 5. So it's -1 and 1 over 5. So somewhere between -1 and -2, but closer to the -1. Finally, for the y-intercept, this is easy. All I have to do is plug x as 0. So this becomes 0. So -1 over 0 plus 1 minus 5, which is -6. So for the y-intercept, all I have to do is take this point here and put it at -6. And we are done. So plot the rational function. And this is it. We have graphed the rational function. Submit the answer. And we're good. Let's try another one. So for the vertical asymptote, we care about the denominator, so x equals 3, because x minus 3 equals 0, so x equals 3. Let's just plug the vertical asymptote at 3. Now for the horizontal asymptote, we want x to be a large number, so it's 6 plus 6 over 1 million, so just 6, so y equals 6, because the fraction here is 0, obviously. So the horizontal asymptote is at 6. For the x-intercept, we want to put y as 0. So 0 equals, this is x-intercept, 0 equals 6 plus 6 over x minus 3. -6 equals 6 over x minus 3. I'm going to take the x minus 3 to the left-hand side. So it becomes -6 times x minus 3 equals 6. Maybe divide by 6 or by -6. So x minus 3 is -1, so x equals to 2. So in this case, the x-intercept will be at 2. For the y-intercept, I put x at 0. So 6 plus 6 over -3, which is -2. So the answer is 4. The y-intercept will be at 4. And I plot the rational function. So how do you plot the rational function on paper after getting these values? Basically, you draw a curve through these 2 points, and then the other curve will be on the opposite side, like this. So these are the 2 curves. These are not very accurate, but Delta will plot something almost the same. So this is the rational function that we have. We can submit like this. Let's try a third problem. With the vertical asymptote, we want the denominator to be 0. So x plus 4 equals 0. X equals -4. For the horizontal asymptote, I'm just going to plot everything at the end. So for the horizontal asymptote, we put x as a large number, -1 over 1 million, or whatever, plus 5. So this is 0. So y equals 5. For the y-intercept, x-intercept first. So for the x-intercept, the order doesn't really matter, by the way. We put y equals 0. We have 0 equals -1 over x plus 4 plus 5. We take the 5 to the other side, so -5 equals -1 over x plus 4. -5 times x plus 4 equals -1. Let's take the -5 to the right-hand side, so x plus 4 equals -1 over -5, which is 1 over 5. So x equals 1 over 5 minus 4. So we need to plot that, so we're not really interested in an improper fraction, for example. We're interested more in a mixed number kind of thing. So, I mean, there are multiple ways to do that. You might think of it in decimals. 1 over 5 minus 4 is the same as 0.2 minus 4, which is -3.8. Or you can think of it as a mixed number. So 1 over 5 minus 4 would be, so 4 minus 1 over 5 would be 3 and 4 over 5. So it's -3 and 4 over 5. Think of it as a mixed number or as a decimal to be able to plot it. So for the x-intercept, I'm going to need to plot that. It's -3.8, so almost -4. Not quite at -4, just a bit before it like this. For the y-intercept, we put x as 0, so this expression becomes y equals -1 over 4 plus 5. Again, same idea. It's either 5 minus 1 over 4 would be 4 and 3 over 4, or you can think of it as 0.25. So 5 minus 0.25 would be 4.75. So for the y-intercept, 4.75 means it's almost 5, not quite at 5, just a bit below. And we already got the vertical asymptote at -4 right there. We got the horizontal asymptote at 5 right there. So this is the function. And we submit. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.